Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. And this episode is, well, it's Linux security best practices. And that sounds like a good course to me. And Don is here to tell us more. Don, good to see you. Don Pizzette.
Hey, glad to be here. And starting off our Linux security adventure, we're going to learn over the next couple of episodes about some of the different security features found in most Linux distros and things we can do to make them more secure than they are by default. But we want to start off with some basic best practices. And these are things that apply to any Linux distro that you run. So in this episode, we're going to talk about some of the different concerns, the problems that we're trying to address with security. And then we'll see a few different technologies to help us kind of meet some of those concerns. Again, trying to stay where this would apply to any Linux system that you encounter out there.
What operational activities fall within cybersecurity, Don?
All right, so cybersecurity is a big umbrella term that wraps up a whole lot of stuff. And so it's really important to set some boundaries on this. And to help, what CompTIA relies upon is what's called the CIA triad. That cybersecurity is made up of three pieces. And I've got a little diagram here that shows that they represent it as a triangle because all three are tied together. Every security practice that we implement should be improving at least one of these three things: confidentiality, integrity, and availability. That's where the CIA comes from, not the Central Intelligence Agency. So each one of these. Now, what do these mean, right? Confidentiality. That means that if I have data that I want to share, I should be able to pick and choose who I share it with.
Yes.
The data should be private unless I specify otherwise. If a hacker gets into my computer and downloads all my documents, it's no longer private, right? So security or cybersecurity should be protecting the confidentiality of my data. Integrity. That means that when I give a copy of my data to somebody, they should be able to tell that data has not been modified, that the data is in the original form that I distributed and it hasn't been tampered with, right? That's integrity. And there's a number of cybersecurity solutions that help to ensure your data doesn't get tampered with. But the last one is the one most people don't think about, and that's availability. That says when I want access to my data, I should be able to get at it, right? If somebody breaks into my server and deletes my data, I can't get at it when I want it, right? Or if the server is offline. Now, it could go offline not just from a cyber attack. It could go offline from thermal conditions. Maybe the air conditioner breaks and it gets too hot and the server shuts down. That's availability. So cybersecurity actually covers things like routine facilities maintenance as well. Air conditioning, physical security, these concepts that we don't normally think of as high tech. Most people don't think an air conditioner is high technology. It's actually pretty amazing what it does, but we don't think of it as a computer. In the world of cybersecurity, we have to. Now, we're not going to focus on air conditioners in this episode. We're going to focus on Linux. And so when we talk about availability there, it's ensuring that our services are running and providing those services on the network as often as possible, if not all of the time. So every security practice we talk about for the rest of this episode, really for the next several episodes, should be addressing at least one, or even better, all three of these. And think about it that way. When we talk about disk encryption, is that giving me confidentiality, integrity, availability? What's it doing? If you come up with a cybersecurity solution that doesn't provide any of these three things, then it's a waste of time and you shouldn't be doing it. That's what's called security theater. People take actions they think will make the network more secure, and it's actually just a big fat waste. So these three things: confidentiality, integrity, and availability, always keep them in your mind.
Are there specific technologies we should be deploying, Don?
With cybersecurity is not a one-size-fits-all, right? So we're going to talk about a number of things over the next, 6 or 7 episodes. Don't turn right around, go home and say, I'm going to implement all of these, right? Because many of them don't play well together, and many of them secure your network in a way that you really weren't at risk for in the first place. You need to look at your network and say, what risks do I have? And then put the solutions in place that protect your risks. Different companies have different risks. And let me just give you an example right here at IT Pro TV. If a hacker were to break into the network here in this building, big deal. We don't have financial data stored here. We don't have private customer data stored here, right? That's all stored off in a different data center somewhere. So this particular network doesn't actually have sensitive information in it. So our needs for cybersecurity in this building are pretty low. But in our main data center, our need for security is much, much higher. So we have a lot of things implemented up there that aren't necessarily implemented right here. And that's just because it would be a waste to implement it here. We don't have that data. So you've always got to evaluate your information, evaluate your system. A Linux desktop is going to be secured differently than a Linux server. And a Linux laptop is going to be secured differently than a stationary machine, because we can lose a laptop. Pretty hard to lose a server sitting there bolted into a rack, right? So you have different needs in different environments. You've always got to keep that in mind. And I mean, you can just take one topic. I'll take authentication, right? If I want to make authentication on my network stronger, I have so many choices. There's the username and password that's by default. Pretty lame, right? And if somebody gets the password now, it's broken. So that's not good. We could do biometrics, right? Fingerprint, iris scan, that kind of thing. We could do one-time passwords, the temporary passwords that are generated and then they get used once and they go away. Or we could do token-based stuff, which is usually one time, but not always. Things like the Google Authenticator, where you've got that kind of authentication going on. We could go crazy and say, I don't want individual machines authenticating themselves. I want to set up centralized authentication. So I'm going to have a Kerberos or an LDAP server that's handling the authentication, and the clients just hand off to it, right? These are all different options. And I've got to pick and choose which ones are right for my environment to improve and increase security, but at the same time, still allow my end users to do their work. That's the give and take of cybersecurity. Because if you make the network too hard to use, all of a sudden you've hurt your company. People aren't able to do their jobs. We've got to find that balance between security and usability.
So we just pick the one that most closely matches our need?
Yeah. I mean, basically that's it. So, on my home computer, I just use a username and password. Actually, I set up that crazy camera thing where it does the face identity, but for the most part, I just use username and password.
I bet you did too.
That camera thing doesn't work so well. But let's say that we were a much more secure network, right? And maybe we work for the Department of Defense, right? Now, I don't want somebody just walking up and punching in my password. I need something more. And so they might leverage something like multi-factor authentication, like in the diagram here. If a user wants to access their system, sure, they have a password they have to put in, but they also have something like a smart card. And a smart card really just has a digital certificate on it. They plug that into the computer. And this is considered one factor of authentication is something they know. They know their password.
Right.
And the other factor of authentication here is something they have, their smart card. And when they provide both pieces, that unlocks the system and allows them access to be able to go in and hit their network resources.
Okay.
That would be overkill for my house. Again, my computer doesn't really have anything sensitive on it at home, and I shouldn't have unauthorized people in the house, so that shouldn't be a problem. But if I had sensitive data, I would certainly want to protect that, and I would go that extra step. And multi-factor authentication, it can be two things like this. So some people call it two-factor or 2FA. But the reality is it's multi-factor. You can have 3, 4, 5 different things. Maybe there's a fingerprint also that needs to be done and so on. My laptop is like that. It's got the camera for Face ID. It's got the fingerprint scanner. I've got a smart card reader on my laptop, and I can punch in a password. That's 4 different factors of authentication. Do I do them all at once? Or do I just pick 2 and use them, right? That's up to me and customizing the environment. So it goes back to every place is a little different. We have to use our judgment on what's right for our environment.
Well, do attackers always focus on user credentials?
That's kind of the main thing. No matter what security you have, let's say you have the most expensive firewall you're able to buy, and you brought in security experts that configured all of this stuff, and it is locked down tight. If an attacker can figure out the credentials of one of your users, all that security goes away, right? If they can VPN into your network using your actual legitimate VPN with actual legitimate credentials, they walk right through the firewall and start to access your internal resources. Credentials are an easy gateway for attackers to get in, right? But assuming they don't have that, they change gears. They focus things a little bit differently, right? So attackers will normally go through 5 different phases. The first phase is just discovery. They're trying to find systems on the network, right? Well, if you have a web server, a mail server, whatever, they have to be visible on the network. Otherwise, people can't get to them, right? So they can find a web server. And once they find it, right, just by scanning the internet, looking for IPs that respond on port 80 or port 443, once they find it, then they enumerate the services on that server. They look for other things that it might be running. They're looking for open ports. And when they find those open ports, now they know what services you're running. They can then try and gain a foothold. That's step 3. Gaining a foothold means using some kind of exploit to be able to enter the system and get it to do things it wasn't intended to do. All right. Once they've gained that foothold, then they want to maintain persistence. That means they're in, they want to stay in. So how do they make sure that we don't come in and say, oh, looks like somebody's in here, let me clean that off, right? So they'll try and escalate their privileges, try and gain root privileges on your Linux box, create backup user accounts, create backdoor tunnels, and so on to make sure that they stay in that system. And then their last step is they cover their tracks. They remove entries from the logs and other things that you would use to identify that they were in there. So those are kind of the steps they go through. And in those scenarios, they don't necessarily need credentials, right? They're going in blind, trying to target a server. Now, that type of attack is very difficult, but they happen every single day. And that's why it's so important that we take steps to make sure our systems are secured. To maybe we can't stop one or two of these steps, but there's 5 different steps. If we can stop them anywhere before that last step, then our data is typically safe. So we want to try that. We want to hinder their progress through our network.
Well, how can we stop or minimize an attack?
So this is where our various technologies come in. And there are a lot of different technologies. For example, chroot. Chroot is a command that stands for change root, and it allows you to create what's called a jail. When I run an application, let's say a web server, right? So I'm running the Apache web server. I need to make it where the world can get to that service because I'm serving up a web page. I can't just block that off. I need people to get to it, right? But if a hacker gets in and breaks into Apache, now they can leverage that to attack the whole rest of the system and potentially gain control of the whole system. So we can use chroot to create a boundary around Apache, or really around any application. So if the attacker breaks in and takes over Apache, that's all they get. They can't go and target the rest of the system. Let me show you a diagram of what this looks like. Normally when you look at your file system, you have your root folder, and then you have other things underneath it, like /bin, /dev, and so on. Well, Apache stores its web files in /var, /www, /html, or, I mean, it can move based on the distro, but usually in that location. So it has access to /var, /www. Well, I could create a chroot jail around that /var, /www folder so that when Apache accesses the system, it would see that jail as its root. It wouldn't even be able to see all these other folders. So it wouldn't be able to attack the rest of the system because it can't even see those files. It only sees what we've put inside of that jail. So in this scenario, the attacker found Apache. The attacker exploited Apache and took it over, but then they couldn't gain persistence. They couldn't get further because the rest of the system is blocked off. So that's one technology that kind of shows how that works. There's other things that we could do, like file auditing, right? That if they get in and start tampering with files, they might cover their tracks, clearing logs. So I can have file auditing turned on that's collecting every time a file changes. And then I can take that, which is all going into syslog, and we can use our syslog to send those logs to another system. And that way, if they flush the logs on your attacked server, you still have a backup somewhere else. They can't cover their tracks. It does require a little bit of configuration, right? I've got to configure syslog to do its exports. I've got to configure file audits, right? Which is not installed on most systems. So for example, like I've got a CentOS box here. Let's see if it's installed. If I try and install the audit package, and we'll see if it's in there. If it tells me it's already installed, it is. All right. So file auditing is already installed here, but it's not actually configured to do a whole heck of a lot. I would need to turn that on and get its configuration set up. Let's see if I have any rules. If we go into /etc/audit, oops, I'm going to need to sudo, and let me get back into /etc/audit, and I'm going to, let's take a look at the audit rules and see what our default is. I haven't configured auditing on this, so it's whatever the CentOS team set as the default. So looking at it here, actually, it does have a bit of auditing turned on. What I'm looking for are the lines that start with -W, because that's where they're defining some kind of policy access. So /etc/Linux is being, /etc/SE Linux is being monitored, right? That's security enhanced Linux. I can see the sudoers file, right? That's an important one. That's who's allowed to use sudo. An attacker would try and create a backup account and give them that sudo access so then they could act as an administrator. I see a handful of other folders in here inside of /etc. And as I look, actually, is that it for files? No, we got some more paths. So it looks like our binaries are protected. There's actually quite a bit in here. Oh, no, that's the end. There really wasn't all that much at all. I didn't see /var /www, which either means it's not being audited or I haven't installed Apache, one or the other. So this list may not be complete. I would need to configure that to say, I need to monitor all the Apache files. I need to monitor this and that to make sure that if there was a change, I would have log messages and be able to see that. And those log messages are stored in /var /log. And an attacker knows this. They know to come in and look for that audit folder And in there, they can find the audit logs. And if they just broke in and started changing files left and right, if they've got root privileges, they might come in and start to tamper with these or just wipe them out, right? Blank them out. So if I'm exporting these to another system, I'm okay. I'll have copies. But otherwise, they will have reset it, and then I won't really know. Here I'm getting that list of all the files that were accessed and what was done. Were they changed? Were they read? Were they written to? It's all logged here. We need to make sure we have a copy of that. So these are all different things that we need to implement as part of our security to ensure that even if an attacker gets in, we still have some rudimentary protections in to try and minimize the impact of that.
Well, that's great. But what about physical security? Couldn't they just steal our computer?
So
They could.
yes, and in fact, that's faster and a lot easier. If you want to be a great hacker, if you can get physical access to a data center or a person's office or whatever, just steal their computer, right? Because then you can go home and you can take your time and you can pop that hard drive out, add it to another system, and start going through it that way.
Mhm.
You don't even have to know a single exploit at that point. I mean, it's just physical theft, right? And that's a big risk with desktops and servers. Not so much. I mean, there is a risk there. Somebody could steal those. With laptops, it's a big deal though,
Mm.
because people do take laptops places, and maybe it's not outright theft. Maybe they just forget it. Hey, I left my laptop on the subway, and somebody else finds it, and now they've got my customer data or patient data or whatever. That's really bad.
Mhm.
So in scenarios where we know the device is at risk, we should be implementing encryption, right? Encryption provides that data confidentiality. We can encrypt the disk so that if somebody steals it, even if they pop that hard drive out and add it to another system, all they see is ciphertext, right? Encryption, bring up a diagram here. The way that encryption works is you have things like plain text or whatever your data is, and you use a key to encrypt it to create ciphertext. And unless somebody has that key, then they can't decrypt it to see what the text is. So if you encrypt your entire hard drive, there's a key that's stored and it's attached to your login identity. And so when you log in, it decrypts and you have access to your information. But if somebody has your device and they can't log in because they don't know your username and password, then they don't have the key and they can't see the data. It's fully protected. Now, I don't know of a Linux distro out there that encrypts by default. Almost all of them have it as an option when you're doing the install. So you can choose to do it, but most of them are not turning it on by default. And that's because, well, a lot of users don't need it or want it or whatever. This is all kind of an evolving technology, but it's super easy to turn on. If you're installing, it's usually just a little check mark you hit and that's it. But even after the fact, it's not that difficult to get encryption turned on for your system. And so you can leverage that to protect the data that's available. Encryption can be done a few different ways. One of the easiest ways, the least painful way, is to do what's called hashing. Hashing is where we don't actually encrypt the data. With hashing, we're worried more about integrity. I don't want somebody tampering with the data. And we can generate a hash where we basically take our data and we run it through a mathematical formula. And that formula uses a key or an algorithm to create what's called a digest. It's kind of like a summary of the data. Now, it's not an entire set of the data, which means it's non-reversible. You can't recreate the data from the digest. But if you have a copy of the data, you can run it through the same formula and see if you get the same digest, the same result. And if you do, you know the data is intact. But if the digest doesn't match, if it's different, you know the data has been tampered with and you can't trust it. So it's a quick way to test for integrity. Now, we can combine that with encryption as well. And when you do that, now you're doing confidentiality and integrity. And in fact, a lot of technologies like IPsec, IPsec does both. GPG, the GNU Privacy Guard, the public version of PGP, pretty good privacy. They both do encryption and hashing, or digital signatures is what it's called when you use it for integrity. So we're basically doing confidentiality and integrity through the use of encryption and digital signatures. So all this stuff kind of gets combined to create the result that we've got right here. So we have to kind of pick and choose. And if we implement these things like physical security or tampering with your data in transit, those become far less of a problem. So on the disk side, I know I mentioned GPG, I mentioned hashing, like using MD5 or SHA hashes. Those kind of things are used on small sets of data. But if you want to do the whole disk, that's where things like LUKS disk encryption comes in. LUKS, I can never remember what it stands for. It's a long one. Linux Unified Key Setup. There we go.
Mhm.
So LUKS disk encryption is supported by most distros, Ubuntu, Red Hat, Debian, CentOS, Fedora, they all support LUKS. And what it allows you to do is generate a managed key store and encrypt entire disks. So that's fully supported. You don't have to go and use third-party software like VeraCrypt or anything crazy. LUKS is natively supported as a part of the Linux kernel, so you've got support there. And if you turn it on, you can get in and encrypt and protect your disk. So it's a great solution for physical security.
Well, can we see an example of using LUKS?
We have enough time. I think I can get through this. Let me run through. Let me just switch over to my CentOS box here. All right. So let's say I've got my CentOS box here, and if I wanted to actually encrypt my boot drive, my root, like where the operating system is installed, I really need to reinstall Linux, because during the install, you can flag that and do your boot disk.
Mm-hmm.
In my scenario, well, not the boot disk actually has to be unencrypted, because we have to be able to find the boot files. So the BIOS has to reach out to the boot files and be able to launch the system, or UEFI. So that little boot part has to be unencrypted. But everything else, like /bin/sbin, all the other stuff, that can be encrypted if you do it during the install. If you don't, like I didn't encrypt mine during the install, in my scenario, I would really need to reinstall or back up my data, encrypt, restore. It would be a long thing. But if I just want to do an external disk or a second hard drive or a second partition in my system, that's easy enough. And we can even do that while the system is online. So I have a handful of disks in my system. I'm going to run blkid and kind of get a list of all the disks that I've got. So you'll see my main disk, this /SDA, and I've got a bunch of partitions there. And as I look down the list, I can see their file system types here. They're XFS or LVM2 member. If they were encrypted, I would actually see that file system type. It would show that it was crypto storage. All right. So I know that none of my disks are encrypted. And I'll take SDB1 here, this guy. All right. So SDB1 is XFS, right? So I see the file system. I know it's not encrypted. I'm going to convert that over to use LUKS. And I'm going to do this kind of the fast way. In real life, I'd probably take a little more time. But the first thing I'm going to do is make sure that's unmounted. So I'm going to unmount /dev/SDB1. All right, it's not mounted, which is good. And then I need to move through and do a couple of things to get this ready. All right, the first thing is, if you're going to be encrypting the disk, it's a good idea to make sure the disk is truly devoid of actual data, right? And if you need to do that, there's the shred command. Shred will actually go through and write ones and zeros to the disk to overwrite any magnetic signature that might be left behind, or crusty data. So you can kind of get rid of that. I'm going to show you the command, but I'm not actually going to run it. And let me just point out real quick, I'm authenticated as the root user right now. I did a sudo -s. Pretty much every command I'm about to run, you need to sudo. So this kind of saves me from typing that. But if you ever do this, make sure you exit out of your root shell, because if you leave it running, you got a root shell running. That's not a good thing. All right, so the shred command, the way it works is you type shred. You can do -v to get some verbose output if you want to actually see what's going on. You can tell it how many times you want to overwrite the disk. So I'll do -- iterations equals, I'm just going to do 1. The DoD recommends you do at least 3, and they actually do like 7 on theirs. So they go really high if they don't just destroy the disk, because that's even more effective. And then you point it to the disk, like /dev/SDB1. And at this point, it would run across that disk and write ones and zeros to it. Or here, it's just a partition that I'm pointing to. So if you run that, it'll take some time, because it's writing to all of those sectors. The bigger the disk, the longer it takes. And when it's done, you know it's truly empty. So I'm going to skip that step just to save time. But in real life, I would certainly do that. Then I'm ready to actually set up the encryption for it. And the utility for that is called crypt setup, right? Remember that what LUKS stands for is that Linux Unified Key Setup. It's the setup of all this stuff that LUKS really makes easy, because you've always been able to encrypt disks in Linux. It was a pain. Now it's a little bit easier, right? So I'm going to do crypt setup. I'll do --verbose to let us see what's going on the screen. And then I'm going to do --verify passphrase. By default, it's going to ask for the passphrase once. I like it to ask twice. In case I screw it up, I can make sure that I typed it right in a repeat. Then I'm going to tell it what I'm doing. And I'm going to call the LUKS format command. And be careful with that one, because the F is capitalized. So it's LUKS format. I need to format the disk as an encrypted disk. All right. Right now it's XFS. So this is going to actually change the file system. I'm going to lose any data on that disk. If I had data on there, I really need to back it up first. I'll encrypt the disk. And once it's encrypted, I can restore the data to it. and now the data will be stored encrypted. All right. So I'm going to do Lux format, and then I'm going to point to /dev/SDB1, pointing to that disk. All right. And when I run that, it's going to come in, and it's going to tell me it's going to erase that disk. I won't be able to recover. I'm okay with that. So I will type, yes, I want to do that. And now it's going to ask for the passphrase. And so I will type in a password, and it will verify it since I told it to do that. And whoops, I picked an easy password, and so it rejected me. So let me pick a harder password this time, and that way I will pass their little test. Let's just make sure I get that in there. There we go. All right, and now it's going to format the disk and put an encrypted file system on it. So it generates a key that's now attached to my user account. It's actually attached to the system, and my user account has privilege to be able to access it. And then from there, it encrypts the rest of the disk using that key. It runs pretty quick. Again, the larger the disk, the longer it can take. But in my case, because it erases everything, it encrypts pretty fast. Now, as I copy data to the disk, it'll actually get encrypted. Now, I can't truly copy data to it yet. If I do the block ID command that I did earlier, remember how I saw all the file systems? Well, now, when I find /dev/SDB1, look at its file system over there on the side. Instead of XFS, it now shows CryptoLux, right? So I know that it's an encrypted disk. But you can't just copy data to an encrypted disk. You have to mount it to unlock it. And once it's unlocked, then we can drop a file system on it and we can start to put data in there and so on. So the next thing I need to do is to mount and format that. So to do that, we're going to run crypt setup again, except this time, instead of running Lux format, I'm going to run Lux open, and the O is capitalized on that. So Lux open, and I'll point to /dev/SDB1, and then I need to mount it somewhere. So by default, it's going to assign a mapper name to this, like a virtual name, and then I'll be able to mount that virtual name somewhere else. So I need to tell it what I want the virtual name to be. I'm going to call mine storage1. All right, that's going to be the virtual name that I assigned to it. All right. Once I've got that, I'm just going to press enter. It's going to ask for that passphrase because if I'm opening it, I've got to know the passphrase. So I'll punch that in. There we go. And now it's going to make sure the phrase works. And now I should have unencrypted access to that disk. And so it should now be created as a virtual disk named storage1, which I should be able to map. Now, before I mount it, I'm going to put a file system on it. So I'll do mkfs. I'll do xfs for this one, since that's what it was before. I'm going to stick with the same file system. And I'll just point to /dev/mapper/storage1, like that. That mapper means it's a virtual name. And when I run that, it should find the disk. It did. And then it formats it. Right now, technically, MKFS doesn't know the disk is encrypted. That's happening behind the scenes, right? So it's just writing a normal file system to it like it was a real disk. And in fact, we just treat that like a real disk. I can mount that. So I'm going to mount /dev/mapper/storage1. And I'm going to mount that to /mnt/storage1. That's a folder I've already created. And when I mount that, now I can go into /mnt/storage1, and I can copy files to it. You know what? Let me do /home/deposit/documents *. I'm going to copy a bunch of files here. And so as I copy those files in, I'm just copying files, right? It's all treated normal to me. But in the background, it's actually encrypting those files and storing them on the disk that way. And I did Lux open to open this thing. If I shut down the computer or if I use the Lux close command, then it's going to lock the disk again and no one will have access to those files. Those are now stored securely right there inside of that partition. So if somebody physically steals my machine, I'm okay. Data's encrypted.
So what other types of encryption should we be using, or could we be using?
There's a bunch. I mentioned IPsec and VPNs. That's encrypting data in motion. So what we just saw, that's data at rest, right? Data that's just sitting there on my disk. But data crossing a network is at a lot more risk, right? That's data in motion. And so there are technologies like VPNs and so on that can help to encrypt that. And I want to show you guys an example of it, but we're definitely out of time now. So I want to show you guys SSH and how Secure Shell works to build an encrypted tunnel across the network. So let's do that in a part 2. If you stick around for that, we'll see the other side of encryption as part of our security baseline.
A little teaser never hurt anyone. Please join us for Linux Security Best Practices Part 2. You're going to be glad that you did. Before we move on, one last thought, Don?
Sure. keep in mind that this is not one size fits all, right? You don't have to do everything that I talk about in these episodes. Think about your environment, think about your data, and make sure the solution is right for what you're trying to secure. Don't go crazy with this stuff because it just makes your life harder.
Linux security best practices part 1. Make sure you join us for part 2. And make sure you watch every single episode of CompTIA Linux Plus. You're going to be so glad you did. It's going to help you now and in the future. And, there's an exam there, so you're going to have more ammunition for when you take that exam. And don't forget about the supplementary information that's inside the course library. It's there to do one thing, help you be even more successful, so check that out as well. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.